Okay, Watkins. At journal page 71, solving logarithmic equations. Steps to solve logarithmic equations graphically. Step 1, graph the left side of the equation. Step 2, graph the right side of the equation. Step 3, find the x value of the point of the intersection. All right, go ahead and finish up that page. All right. Example 1, solve the equation graphically. Enter your answer in simplest form. Log base 6 of 2x equals 2 times log base 6 of x plus 1. All right, take a few moments to draw your graph. All right, now let's go ahead and graph that in our calculator. So we're going to go on, new document, no, add graph. Now before we do anything else, we want to do menu, view, grid, line grid, and we want to adjust our window to match what's on the paper. So we can see our x min is 0 and it's to 1.8 counting by 0.1s, and our y min is -8 going to 8 counting by 1s. Okay, so we're going to go to menu, window zoom, window settings. So our x min is 0, the max is 1.8, and they're counting by 0.1. The y min is -8, the y max is 8, and they're counting by 1s. Press OK. All right, now we can graph the left side of the equation, which is control log base 6 of 2x. All right. Now we need the point, so we're going to press Control T. Now we need to get the points to adjust for the table, so we need to go to Menu, Table, Edit Table Settings. Now we're going to start at 0.1, and we're going to count. Well, actually, no, I'm sorry. Let's go start at 0, and we're going to start and count by 0.1. Okay, press OK. There's an error, that's because of the 0, but that's okay. All right. So now we can graph our values. So we know 0 is undefined. 0.1 is -0.8. Okay, so let's graph that point. Okay, 0.2 is -0.5. Okay, 0.3 is -0.2. 0.4 is -0.1. 0.5 is 0. 0.6 is 0.1. 0.7 is 0.18. 0.8 is 0.26. 0.9 is 0.3. 1 is 0.38. 1.1 is 0.44. 1.2 is 0.48. And again, we're just approximating these points. 1.3 is 0.5. 1.4 is 0.57. 1.5 is 0.6. 1.6 is 0.6. 1.7 is 0.68. And 1.8 is 0.7. All right. So we have our points. We're going to graph the left side in yellow. Now we know that it falls along the asymptote there. It's going to go through the points there. Okay. All right. Now we're going to graph the left side. Okay. So what I'm going to do is press Control T, press Tab, and I don't want the left side, I just want the right side. So 2 times Control log base 6. Whoa. Base 6 of x plus 1. Okay. So I'm press Control T, and we're going to go to Menu, Table, Edit Table Settings. We want to start at 0, and we're going to count by 0.1. Okay, we're going to ignore that. All right. So 0.1 is negative 1.57. 0.2 is negative 0.7. 0.3 is negative 0.3. 0.4 is negative, so it's very close to there. 0.5 is 0.2. 0.6 is 0.4. 0.7 is 0.6. 0.8 is 0.7. 9 is 0.8. 1 is 1. 1.1 is 1.1. 1.2 is 1.2. 1.3 is about 1.2. 1.4 is 1.3. 1.4 is 1.5. 1.6 is 1.5. 1.7 is 1.6. And 1.8 is 1.6. All right. So we know that this falls along the asymptote, and it goes up through those points. All right. As you can see, finding the point of intersection by hand is somewhat difficult. So take a few seconds to finish that graph. All right. Now we're going to use Desmos to find the exact point of intersection. So I'm going to write y equals, move this out of the way, functions, miscellaneous, log base 6 of 2x, and then y equals 2 times log base 6 of x plus 1. Okay. And then we want to zoom in a little bit. You want to be careful because that dot popped up, but that's not the point of intersection. This is the point of intersection right there. Okay. Now, in this problem, when you do your assignment, it's going to want the exact answer. Well, we know that 0.333 is 1/3. Okay. So the x coordinate of the point of intersection is 1 divided by 3. So the solution of the equation is 1/3. All right, go ahead and finish up example 1. All right. Take a look at example 2. Solve the equation graphically, round your answer to 2 decimal places. So we have 11 equals 3 times log base 2 of x. Take a moment to graph that on your paper. All right. Now, to graph the left side, that's easy. We don't need to use a calculator. That's just a horizontal line at 11. Okay. Now we're going to graph the right side using the calculator. All right, so we want to go to On, New Document, No, Add Graph. We want to go to Menu, View, Grid, Line Grid, and we want to adjust the window to match. So this goes from -2 to 15 counting by ones. This goes -2 to 15 counting by ones. All right, so we're going to go to Menu, Window Zoom, Window Settings, -2 to 15 counting by ones, -2 to 15 counting by ones. All right, now windows adjusted. Now let's graph 3 times control log base 2 of x. Press enter. Press control T. Now we can see here that it's undefined starting at 0. So our first point will be 1, 0. Okay, our next point will be 2, 3. Let's see if we can just use whole numbers. 4, 6. When we only have decimals, we'll have to approximate, but if we can use whole numbers, let's use whole numbers. 8, 9. And then it looks like, let's just use 15, and that's 11.7. So 15, 11.7. It's about right here. All right. So we know that it goes along the asymptote here up through the points there. Okay. Now, as you can see from the graphing it by hand, it's somewhat difficult to find the exact point of intersection. So I'll give you a few seconds to finish up your graph. All right. Now let's use Desmos to find the exact point of intersection. So we have y equals 11 and y equals log base, almost forgot, 3 times log base 2 of x. Let's minimize that. I'm going to press the home key and I'm going to zoom out until we have our point of intersection right there. Okay. Now it says to round to 2 decimal places, so that'd be 12.69. Well, that rounds to 12.70. And again, we're only looking at the x value. So the x coordinate of the point of intersection is 12.70. So the solution of the equation is 12.70. All right, go ahead and finish up example 2. All right. Let's take a look at example 3. Solve the equation graphically. Round your answer to 2 decimal places. So we have 9.6 minus log base 5 of x equals 4 times log base 5 of x plus 0.7. All right, first off, take a few moments to graph your graph on your paper. All right, now you have that graphed. Let's go to our calculator. So we're going to go to On, New Document, No, Add Graph, Menu, View, Grid, Line Grid, and we want to adjust the window. So we're going to go to Menu, Window Zoom, Window Settings, and you can see from your paper the x-min is 0, the x-max is 19, counting by ones, the y-min is -7, the max is 10, and we're counting by ones. Okay, that's okay. Now we're going to graph the left side, so 9.6 minus control log base 5 of x. Press enter. Press control T. Okay. And we want to start at 0. It's undefined. So 1, 9.6. 2, 9.1. 3, 8.9. Again, you're just going to have to approximate the points. 4 is 8.7. 5 is 8.6. 6 is 8.4. 7 is 8.3. 8 is 8.3. 9 is 8.2. 10 is 8.1. 11 is 8.1. 12 is 8. 13 is 8. 14 is 7.9. 15 is 7.9. 16 is 7.8. 17 is 7.8. And 18 is 7.8. And let's go one more. 19 is 7.7. Alright. So you have your graph. I'm going to graph that in yellow. Now we know it comes along the asymptote and it goes through these points. Alright. So now let's graph the right side. Now you'll see your curve. If you did it like me, it's not a nice smooth, just because approximating points like that is somewhat difficult, but it's curved enough, so we have that. So now we're going to go Control T, tab, we're going to delete this one, and let's graph the right side. So 4 control log base 5 of x plus 0.7. Okay, so now press Control T, and we're going to start at x is 0, so undefined. 1 is 0.7. 2 is 2.4. 3 is 3.4. 4 is 4.14. 5 is 4.7. 6 is 5.15. 7 is 5.5. 8 is 5.8. 9 is 6.1. 10 is 6.4. 11 is 6.6. 12 is 6.8. 13 is 7.07. 14 is 7.2. 15 is 7.4. 16 is 7.5. 17 is 7.7. 18 is 7.8. And 19 is 8. Alright, so we know that this falls along the asymptote and goes up through the points like so. Alright, so again you can see it's very difficult to find the exact point of intersection graphing on your paper, so now let's use Desmos to find the exact point of intersection. Alright, so we can come over here, exit out this. Let's go to the home screen. Y equals 9.6 minus log of 5 of x, and then y equals 4 times log base 5 of x plus 0.7. Okay, so let's minimize that, and then we're going to zoom out, and then you can see they intersect right there, and they want 2 decimal places, so it's 17.55. Okay, so there's your graph. The x-coordinate of the point of intersection is 17.55. So the solution of the equation is 17.55. All right, go ahead and finish up example 3 and have a wonderful Wildcat day.